Revisiting Monocular SLAM with Spatio-Temporal Scene Modeling. In this work, we propose SLAM-MER, a new modular C++ framework for uncalibrated monocular SLAM that combines geometry principles with recent data-driven techniques. The proposed pipeline improves on the traditional SLAM framework and achieves low-latency real-time performance at 80 frames per second. The goal of SLAM is to build a map of the environment while tracking the camera's location. Our map is composed of sparse map points, keyframes, and 3D cells. Additionally, we use the map points as anchors to obtain a semi-dense reconstruction of the scene. Localization is the first of two modules in the pipeline, and its main function is estimating the pose of the current camera frame. For it, we gather 3D points from the map temporally by selecting points from keyframes in a temporal window, and spatially by gathering points from the closest visible 3D cells from the current camera pose. We match the 3D points gathered from the map with 2D key points from the current frame, obtained with alike features. Having 3D to 2D correspondences, the camera absolute pose is estimated by solving PNP with RANSAC. Once certain criteria are met, we create a keyframe using the current frame. These mark places in the environment that add new data to the map. Since our input is monocular, we use a feed-forward depth estimator to obtain depth, but only per keyframe. Each new keyframe created adds new keyframe to keyframe and keyframe to point connections to the adjustment module. The adjustment module creates and updates the map. To ensure a reliable trajectory by fixing long-term trajectory drift, we check for loop closures. Loops are first detected using visual place recognition, and later verified geometrically by pose estimation. The core of the adjustment module lies in a covisibility graph that is continuously updated with the new connections from the localization module and loop closure, and incrementally optimized using ISM2. Keyframe to keyframe connections represent relative pose measurements between keyframes, and keyframe to point connections represent a tuple of 3D to 2D projection and 3D to 3D Euclidean distance constraints. We evaluated our approach in camera pose estimation by evaluating the trajectory error in two datasets. We can observe that we are on par in accuracy with the best methods with a substantial improvement in efficiency. Secondly, we evaluate 3D reconstruction. We note that we are the best performing in accuracy. However, due to the sparse anchors used, completions and chamfer distance metrics do not reach the values of the dense approaches. Here's an example of the pipeline running in real time. This is a second example of SLAM-MER being run. To conclude, this work introduces a new approach for real-time uncalibrated monocular SLAM, where we propose a new spatio-temporal approach for querying 3D map points that leads to an improved camera localization. Additionally, unlike the baselines that estimate depth for every frame, we argue that 3D-2D correspondences are sufficient and depth is only needed for keyframe creation. Finally, this modular C++ framework has been open-sourced. For any questions, feel free to contact us.